Hi, so in this video we'll continue our chapter of energy for GCSE AQA Physics Combined Science. Over here we'll discuss about the changes in energy. Now before that we have to understand what are the types of energies that are being possessed by an object. Let's suppose a moving object has kinetic energy. So we will discuss about kinetic energy, and other energy that we will discuss is the elastic potential energy. Elastic potential energy is the energy in a compressed or a stretched spring. And then we'll move on to the gravitational potential energy. The gravitational potential energy is the energy possessed by an object due to its height. So these are some of the major types of energies that we'll discuss. Moreover, we'll also discuss the change in thermal energy, how the thermal energy of an object changes. So in these changes of energy we will be working on these four major types of energies. Alright, so now let's start off with the first one, the kinetic energy. So kinetic energy. Let's define kinetic energy first. So the energy possessed by a moving object is called the kinetic energy. Let's suppose there's a car and it is moving on the road. So the energy that is being stored in this car is the kinetic energy. We represent it with Ke. Now let's go into the formula for the kinetic energy. So kinetic energy is equal to half mv square, where m is the mass of the moving object and v is the velocity of the moving object. The unit for this kinetic energy is joule, and we represent joule with capital J. Now this joule is if we convert this unit into the system international unit, it will be equal to kilogram meter square per second square. All right, so this is what kinetic energy is all about. Now the next type of energy that we have to discuss is elastic potential energy. Elastic potential energy. So elastic potential energy is basically, it is the energy possessed by a compressed or a stretched spring. The energy possessed by a compressed or a stretched spring. So this energy is called that energy that will be stored within the spring. That energy is called the elastic potential energy, which means that if we release that object from its compression or its extension, the object will move. So the elastic potential energy will be converted into the motion of the object, and in other words we can say that the elastic potential energy will be converted into the kinetic energy. So now let's go into the formula. So elastic potential energy, I'll represent it with EPE, stands for elastic potential energy. That will be equal to half kx square. Now this k is basically the constant and we call it the spring constant. The value of the spring constant will be higher if the spring is stiffer and the value of the spring constant will be lower if the spring is less stiff. This x, we call it extension. The extension that will be caused in the spring will be represented by x. Now let's understand this extension over here. So I'm gonna draw a spring. This is a stand on which there is a spring that is placed over here, and some mass is attached with the spring. So when this mass has been attached with the spring has been extended like this. So this is the extended length of the spring. So originally from here to here, this was the original length. I'll represent it with small l, and from here to here, let me draw a straight line. So from here to here, this is the new length. Now extension is basically the difference between these two lengths. So from here to here, this will be the extension. So I'll say that x will be equal to the new length minus the old length. So this x will be the extension, and in other words we can say the change in length when a mass is being hanged with the spring, or in other words if a force is being exerted onto the spring. Okay, so now let's discuss about the units for the elastic potential energy. The units for all types of energies are same, that is joule. So for this one, the unit is also joule because it's a type of energy, so the units are same for all the types of energies. So this is it from the elastic potential energy. Now the next type of energy is the gravitational potential energy. Gravitational potential energy. Now you can see, as the name suggests, gravitational, like it will be something related to the gravity. So it is basically the energy possessed by an object due to its height. So the energy possessed by an object due to its height is called the gravitational potential energy. Let's suppose this is ground. The object is placed at the ground. At this position, this object has zero gravitational potential energy. If we lift this object and move it up to a certain height, let's suppose over here, and this height is h, so we can say that now this object has some gravitational potential energy, and in order to find out that gravitational potential energy, we use the formula that says GPE is equal to, GPE stands for gravitational potential energy, so GPE is equal to mgh, where m is the mass of the object, g is the gravitational field strength, and the value that we use for the gravitational field strength is a constant, and that value is equal to 9.81. all right, and this h is the height of the object that it has possessed. So m is constant because the mass of the object will not change if it covers some height. So m is constant, g is constant, h can be varied. So we can say that if the object has more height, it possesses more gravitational potential energy, and if the object has less height, it will have less gravitational potential energy. Okay, now the next type of energy that we see is the thermal energy, but we'll discuss the change in thermal energy. Change in thermal energy. So what is a change in thermal energy? In simple words, if the temperature of an object increases or decreases, if the temperature of an object increases or decreases, that increase or decrease in temperature causes the change in thermal energy. So if the temperature of an object increases or decreases, there will be a change. There will be a change in thermal energy of the object. Now, this thermal energy is usually represented with delta E. This triangle sign is called delta, and this delta represents the change. So change in energy will be equal to mc delta theta. This symbol is called theta, and this symbol represents the change in temperature. This whole thing represents the change in temperature. Now m, this represents the mass of the object whose temperature has been changed, and this c, it represents the specific heat capacity of the object. We will discuss it after this topic. So it represents the specific heat capacity of the object, and this delta E, it represents the change in thermal energy. Because it's a change in thermal energy, because it's energy, so the units will remain same, that is joule. All right, now let's move on to this property of the object, that is specific heat capacity. So let's discuss specific heat capacity. First of all, I'll write its definition, then I'll explain it. So specific heat capacity, it is the amount of heat required by an object of 1 kilogram to change its temperature by 1 Kelvin or 1 degree Celsius. So let's suppose this is the object, and we put a thermometer, like a digital thermometer, on this object, and right now it has a temperature of, let's suppose, 30 degrees Celsius. Now what we're gonna do is we're gonna put a Bunsen burner, and I'll heat this object. So the amount of heat, and this object is equal to, the mass of this object is 1 kilogram. So the amount of heat that this object is required to increase its temperature from 30 degrees Celsius to 31 degrees Celsius, that amount of heat is basically the specific heat capacity of this object. So we can say if the specific heat capacity of an object is more, it requires more heat to increase its temperature by 1 Kelvin. And if the specific heat capacity of an object is lesser, it requires less heat energy to increase its temperature or decrease its temperature by 1 Kelvin or 1 degree Celsius. and this is the intrinsic property of an object, and it varies from material to material. Some materials have high specific heat capacity, some materials have low specific heat capacity. So this is it from this topic of changes in energy, and we'll discuss the next one in the next video.